Good morning, students. I'm Reena Dayani and I'm your chemistry teacher. So, we are on the first chapter of our chemistry, that is chemical reactions and equation. In our previous lecture, we have discussed about what actually the chemical reactions are. Now, we are proceeding to our next topic, that what are the chemical equations. So, our next topic is chemical equations. So, any chemical change is accompanied by the chemical reaction, and the method of writing the chemical reaction is known as chemical equation. So, if I talk about any change, if I say about any chemical change, this chemical change will be accomplished by chemical reaction, and any chemical reaction can be expressed by chemical equation. So, any chemical change occurring is accomplished by chemical reaction, and chemical reaction can be described in the form of chemical equation. So, it is all about the chemical change, reaction and equation. So, now we are on our topic, that what actually the chemical equations are. Chemical equations are basically the shorthand notations to express any chemical reaction. So, what is chemical equation? Chemical equations are the shorthand notations to write any chemical reaction. So, any chemical reaction can be represented by a shorthand notation, and it is basically the chemical equation. Now, if we want to express the chemical equation, we have two methods here, that is word equation and symbol equation, that I have already discussed, but I'm telling you now in a very short form that how the chemical equation can be represented. So, chemical equations can be represented by the two ways. Chemical equation can be represented in two ways. First is word equation and second is symbol equation. So, we have our first category, that is word equation, and second is symbol equation. Word equation, sometimes also known as sentence equation, because the statement is written basically in the sentence form. So, what is the basic difference between the word equation and sentence equation? So, we have our first topic, that what actually the word equation is. So, word equation means writing any equation in the symbolic form or a sentence form. So, we will write the equation in sentence form. So, word equation will be more clear with the help of an example. So, I am considering an example here. So, for the word equation, we have an example. Suppose magnesium ribbon is burned in the presence of oxygen. What actually we will get? We will get a white powdery substance that will be of the magnesium oxide. So, what is the word equation? Magnesium burns in a white dazzling. It will produce magnesium oxide. Mg plus O2 will give us MgO2. So, it is basically the magnesium oxide. Here, we have taken a white ribbon of magnesium and provided a flame it in a Bunsen burner flame. and what we will get magnesium oxide, which is basically a white powdery substance. It is white powdery substance. So this equation which I have written here is the symbol equation, is a sentence equation, is a word equation, because it will not tell us about the symbols of the any element. So what will be the drawback of writing the sentence equation? First, it is quite lengthy and it is time consuming. So we have the drawbacks of this equation, and these drawbacks are, we cannot always write the equation in sentence form. So we have two drawbacks here. First, it is lengthy, and second one, it is time consuming. So these are the two drawbacks of writing the equation in sentence form. So what alternate we have find for word equation? We have with our second category of equation, that is symbol equation. Symbol equations are the equations in which equation is basically expressed in the symbolic form. So we have our second category, that is symbol equation. So in the symbol equation, we will write the symbols to represent any equation. We have equation in form of symbols. So we will write the equation in the form of symbols here. Now we will take an example to understand the symbol equation. Suppose we have an example. I am taking the similar example of word equation to represent the symbol equation. It is represented in the symbolic form as for magnesium we have a symbol Mg, for oxygen it is O2, and what we will get? We will get MgO. But this equation is not balanced, so balancing or unbalancing of the equation is our next topic. Firstly, I am writing the symbols of this. So word equation has the equation in the word form, and the symbol equations we have represented it in the form of the symbols. So students, you have seen here, writing in the form of the symbol is not quite lengthy, and it is not time consuming, and it is easy to understand the symbol equations. So finally, the symbol equation is adopted as a basic equation. So it is all about the chemical equation. I am repeating once again, any chemical change will be accomplished by chemical reaction, and the chemical reaction can be expressed by the chemical equation. Now we will deal with our next topic, that what are the limitations of any chemical equations, what are the specialties of chemical equation, and what are the rectification method of this chemical equation. So firstly, we will discuss about the limitations of chemical equation. So our next topic is limitations of chemical equation. Now our next topic is limitations of chemical equation. What are the basic limitations of chemical equation? Suppose I am writing any chemical equation. So firstly, what I have not observed here, I cannot get the information about the state of a substance. So first limitation is, we do not get a information whether the substance or element is solid, liquid or gas. So our first limitation is, we do not get idea about state of substance, whether it is solid, liquid or gas. Now, our second limitation of the chemical equation is we do not get an idea about the completion of the reaction or concentration of the reaction. So, our second point is we don't get idea about concentration. So, we do not get idea about the concentration. It means how much reactant or product is present in a particular equation. Thirdly, we do not get idea about the conditions of temperature, pressure and catalyst. So, our third point is we do not get any idea about conditions of temperature, pressure and catalyst. So, this is the third limitation, that we will not get an idea about the completion of the reaction. Fourth point is we do not get an idea whether the reaction is reversible or irreversible. So, we do not get idea about reactions reversibility, whether the reaction is reversible or irreversible. Then we do not get the idea about the completion of the reaction, whether the reaction is completed or not. So, our fifth limitation is we do not get idea about completion of reaction. So, these are the some of the limitations that we do not get about the chemical equations, but these processes are rectified and we will get the idea about certain points among this. So, these are the basic limitations of any chemical equation. So, these are actually the limitations of the chemical equation. Now, we are proceeding to our next topic, that is what are the specialties of chemical equation. So, after the limitations, we have certain specialties of the chemical equation, that is, if I write any equation in the word form or the symbol form, I have to write the reactants on the left hand side of the equation, and I have to express the products in the right hand side of the equations. So, the first specialty is reactants are written in left hand side of the equation, and second point is products are written in right hand side of the equation. So, these are the two specialties of the chemical reaction. Now, the third point is the arrow. What will the arrow indicate? The arrow is put it between the reactants and products to separate them, and the head of the arrow will indicate the direction of the reaction. So, the third point is arrow placed between reactants and products and the head of the arrow will indicate the direction of the reaction. Head of the arrow indicates direction of reaction. So, these are the sum of the specialties of the any chemical equation which we are understanding with the help of an example. Suppose I am considering the example Zn plus H2SO4 give us ZnSO4 plus H2. So I am considering this basic example. So according to the specialties of the chemical reaction, what we are observing here, zinc and sulfuric acid that are reactants are written on the left hand side of the equation. These are reactants, and zinc sulfate and H2 are the products which are written on the right hand side of the equation. So these are the products, and this arrowhead is indicating the direction of the reaction, that is zinc and sulfuric acid after reaction will give us zinc sulfate and hydrogen gases evolved in this case. So these are some of the limitations and these are some of the specialties of the chemical reaction. If you want to copy it, please copy it now. Now we are proceeding with our next topic, that what are the rectification processes of these limitations. So rectification process is done to observe the drawbacks that are observed in the chemical equation. So we are with our next topic, that what are the rectification process of chemical equation. So now we are with our next topic, that is rectification of chemical equation. So in the rectification process, we will rectify the drawbacks that are occurring in chemical equation. So our first drawback is it do not specify the state of a substance. Now if I am writing certain equation, I will specify the state of a substance. So in the rectification process, we have our first topic, that is state of element. So the state of the element is shown in the rectification method. So if I am considering the solid, I will write small s in the bracket. So here we have some points. If it is solid, we can write small s. If it is liquid, we will write small l. If it is in the gaseous form, we will write small g. And if it is in the aqueous form, aqueous means water is dissolved in it, so we can write AQ. So state of the elements is represented by this equations. Now we are on our second topic, what does it specify? Second topic is, it will tell us about the reversibility of the reaction. Second topic is reversibility of reaction. So we came to know about the reversibility of the reaction, whether the reaction is reversible or not. Reversible reactions are those reactions which can be proceeded in both the direction, but the irreversible reactions are can taken place in only one direction. So it will tell us about the reversibility of the reaction. So if the reaction is reversible, we can indicate it by the arrow this. If the reaction is irreversible, if the reaction is irreversible, we can specify it by only a single arrow, whether it is in the this direction forward and whether it is in the backward direction. So this is the symbol for reversible equation and this is the symbol for irreversible equation. Now our third drawback is we came to know about the conditions of temperature, pressure and catalyst. Temperature, pressure and catalyst. So if we want to determine the condition of temperature, pressure and catalyst, what we will done, we will do a simple equation written in the symbolic form and on the arrowhead what we will represent, above this arrow we will write the condition of temperature, pressure and catalyst. Now I am showing you with the help of the example. Suppose we can understand the process of synthesis of ammonia by Haber's process. So our example is synthesis of ammonia. Synthesis of ammonia is basically known as Haber's process. So synthesis of ammonia can be called as a Haber's process. So what we will do here, we will write the equation in the symbolic form. So first we have N2, then we have 3H2, then we put an arrow and what we will write 2NH3. So if I write again it in the form of the words, we have N2 for nitrogen, we have 3H2 for hydrogen, and if I take 2NH3, 2NH3 is basically the ammonia. Now we have to mention the condition of temperature, pressure and catalyst in this equation. So what we will do, this reaction has been taken place in the presence of 300 degrees Celsius temperature, 200 atmospheric pressure, and we will put the catalyst in this equation, that is iron fillings with molybdenum. So on the arrowhead I have specified the condition of temperature, pressure and catalyst, and these three terms have been rectified by the process of rectification. So this is the condition for temperature, this is the condition for pressure, and this is the condition of catalyst, that is Fe plus molybdenum. So we have represented all these three. Now we are proceeding with our fourth drawback, that is to determine whether the reaction is exothermic or endothermic. So our fourth topic is to determine whether the reaction is endothermic or exothermic. So to determine the nature of the reaction, I have described you in the previous lecture that the exothermic reactions are those reactions in which the heat is liberated or evolved out, and endothermic reactions are those reactions in which the heat is absorbed for the completion of the reaction. So how will we determine the nature of endothermic and exothermic? Firstly, in endothermic reaction, what actually happens? Heat is absorbed. So if the heat is absorbed, we will indicate it by the negative sign. Next, the reaction will be the exothermic. So what we will do in the case of exothermic, in case of exothermic reactions, heat is evolved. So what we will do, we will represent it by the positive sign. So In case of endothermic, negative sign is used, and in case of exothermic, positive sign is used. So I am giving you an example for both these equations so it can be understandable. Firstly, I am writing the equation N2 plus 3H2 gives us ammonia. So in this process, 22400 joule energy is evolved. We can write the unit of energy in joule. This is the formation of ammonia, and I am showing here plus sign. It means the reaction will be the exothermic in nature. Now we are taking another example for endothermic reaction. N2 plus O2 gives us 2NO. So what we have seen in this equation, the energy that is 43200 joule is represented with a negative sign. It means this reaction will be in endothermic nature. So positive sign will going to represent the exothermic nature of the reaction, and negative sign will indicate the endothermic nature of the reaction. So what are the rectifications we have done? Firstly, we will know about the state of the element. Secondly, we have checked the reversibility of the reaction. Thirdly, we have mentioned the condition of temperature, pressure and catalyst. And fourth, we will understand the endothermic and exothermic nature of the reaction. Now, lastly, we will check the precipitation is formed or gas is evolved. So, our final rectification process will be evolution of gas or precipitate is formed. So our final topic for this will be evolution of gas and the formation of PPT. Suppose in certain reaction a gas is evolved, then how will we know the gas is evolved? We will indicate it by an upward arrow. So if gas is evolved, we will indicate it by an upward arrow. And secondly, if precipitate is formed, what we will do? We will indicate it by an downward arrow. So the upward arrow will show the evolution of the gas and the downward arrow will show the formation of PPT. So upward arrow will indicate the evolution of the gas and downward arrow will show us the formation of precipitates. So now we will understand this with the help of an example. Example for this I am writing here. Suppose we have calcium oxide plus carbon dioxide. So what we will observe here, we will get CaCO3. Here CaO is calcium oxide, CO2 is carbon dioxide, and what we will get? We will get CaCO3, which is used, which can be called as a marble. So it is calcium carbonate. So we have considered this simple equation here. CaCO3. So if I consider the CaO, I can write it as a solid. If I am considering carbon dioxide, I can write it as a gas. And what we will get? We will get calcium carbonate, which is again solid. And after reaction with this, CaCO3 will going to form the precipitate. So we can write in bracket here PPT. So PPT will formed in case of calcium oxide and carbon dioxide. So this will be the symbolic representation for precipitates. Now what we want to observe? We want to observe the evolution of gas in the reaction. So we are again considering an example for evolution of the gas. We have an example, zinc react with sulfuric acid gives us ZnSO4 plus H2. what you have seen here, we have seen here the H2 gas is evolved in this process. So if the hydrogen gas is evolved, it may be shown by the arrow. And the last point, we can also write the nature of the acid used, whether we are using the dilute acids or concentrated acids. If I am using the dilute acid, I will write DIL below the H2SO4, and if I am using concentrated acid, I can write it as CONC. So it is all about the rectifications method that we have used in the chemical equation. If you want to copy it, please copy it. Now we are with our next topic, chemical reaction and chemical equation we have discussed until now. Now we are with our next topic, that what are the balanced and unbalanced reaction and how will be the balancing of the chemical equation can be done. So our next topic is balancing of equation.